about the solid principle today. Can I? Yeah, okay, this is big enough. So what is a solid principle? Solid principle are the object-oriented design concepts related to the software development. And solid is the acronym for the 5 other class design principle. It's I would say acronym for the single. For the first one, S means the single responsive principle, and the O means open close principle, and L means the Liskov substitution principle. Liskov substitution principle, and I means the interface segregation principle. Okay, let's meet what it means. Okay, just the name. Okay. And this means the dependency inverse principle. So it's a. This one is just the represented name similar to this very directly. Means when you create a class, right? And the class just take responsibility for a single response, which means you better separate the class into the small function as possible. That is the single response here. So let's see. Single response, right? Have only one responsibility, and this responsibility should be entire encapsulated within a single class. Each class each class should be responsible for a single part of functional of the system. And then is the open principle. Okay, let's start from the whatever. Okay, so for the open principle, software entity should be open for the extension, closed for the modification. So this is means for here. And this means that the software entities such as class, models, or functions should be open to the extension, is right? And which means which means it's components. Lots of people can use this component, and also you can DIY what you want. So it's kind of like that's a way to understand this. And here openness to extension is from the perspective of provider, while closure to modification applies to the caller or client. So this is the explanation about this word, this sentence. And the next is called the Liskov substitution principle. Am I pronounced right? Liskov substitution. This means replace. Okay. Liskov replace principle. In simple terms, a subclass can extend the functionality of the superclass, but it should not alert exit function of the superclass. So this will have some here. A subclass can implement abstract methods from the superclass, but should not override concrete or non-abstract methods. Okay, better not to use that. But sometimes we still use the override. A subclass can add its own unique methods. It's more like a inherent part, right? The children can inherit from this. When a subclass overload superclass methods preconditions, input should be less strict than the superclass methods. When the subclass implement the superclass methods either through the overriding, the post conditions should be as strict as or stricter than those of superclass. See? So what's the meaning of this? It means that superclass should not contain constraints that superclass does not have. Okay, so which means the parents should be for the content strict, right? It should be covered better. It's more than the children. Okay, this is the mean here. And for the interface segregation principle, its clients should not be forced to depend on the interface they do not use. which means this is kind of like an interface. You have an interface, a lot of the function, whatever inside. You don't need to implement all of them. All you need is to implement what you need. So that's kind of like when you write the interface is same thing. Dependency inversal principle. It means high-level models should not depend on low-level modules. Yeah. Both should depend on abstraction. Abstractions should not depend on the detail, but details should depend on the abstraction. It's kind of like from the high-level idea and then go through the detail. It's kind of like this direction. We do not reverse direction. From the high-level idea, go to the detail. Yeah, in the software development is essential not only to complete the current business functionality, but also consider the maintainable and the reusable of the entire project. The projects we developed solely are not solid for our own use. They also require collaborations maintained by other developers. Therefore, we should write the code as clean and consistent as possible. If we ignore this aspect, the projects can become unmanageable mess, and its growth, its structure will only deteriorate. What this means? It will be the worse. Eventually, we might even find our program is somehow running stable despite being built on ton of the numbers of bugs. Okay, so this is the solid principle. Let's see more close about the code part. The simple responsibility principle, right, should have just only one responsibility. You can see here we have the people. People can do a lot of things. So we just separate it as small as possible. So we can separate like a coder, right, worker, and there has some function inside in the worker coding, right. So original is the huge one, and separate it small as possible, and just give this one function to take one responsibility. Yeah, this restructure makes it clear and organized. The same principle can apply to separate concerns across different layers such as mapper, servers, and controller for different functionality. It aligns with the design of microservers, where each service is responsible for a single function. Yeah. So this is a run. You can see it's a run example here. We have something, and this not separate as detailed as possible. So we better to separate it, like involves printer, import calculator. So second one is called the open-close principle. So what is open-close principle? It's also an essential object-oriented design pattern. Yeah, the software entities should be open for the extension but closed for the modification. So I'm okay to, if you want to use me, it's okay, and based on your DIY, whatever, this is but I'm not okay to modify. It's quite similar for the Liskov substitution principle. So this means that for the open-close principle means a software entity such as class, model, or function should be open for the extension but closed for the modification. Right? Let's see this example. We have the coder, right? Java coder. We can extend the coder to writing this one, to modify this. So by providing an abstract coder class that defines the coding behavior here, without implementing it because it's used abstract, we allowed each specific type of programmer to implement their unique way of coding. This creates a flexible structure that extends with the new type programmer, ensure the longevity and adaptability. In fact, as we review everything we learned so far, it seems like the open-close principle has been applied in many places along the way, right? So we kind of like open to this. Let's see. So this is the run example, right? So we can see every time if we want to add something here, we need to change the apply discount. We don't want to do that. So it's kind of like this one is original one. We better not, it's better for the close, better to define something. And this is kind of like a extension. So we better write it in this way. Like we can define this one is the original one is called discount strategy. We don't need to modify this one. And every time we want to create specific type of the discount, right? So we can just implement this one and not change the original definition defined here. So Black Friday discount to write this one. So separate it. So the third one is called the Liskov substitution principle. The Liskov substitution principle is a specific guide for handling the subtypes. It was the first introduced by these guys. Yeah, this is the name. Liskov in her. Okay, it's girl. 1987 speech titled Data Abstract and Hierarchy. Objects of a subclass should be replaceable with objects of the superclass without alerting the correctness of the program. In simple terms, a subclass can extend the functionalities of the superclass, but it should not alert the existing function of the superclass. A subclass can implement the abstract method from the superclass, but should not override the concrete methods. Okay, so the second one is subclass can add its own unique method. The third is when the subclass overloads a superclass method, the method's preconditions input parameter should be less string than the super. Yeah. The fourth one is when the subclass implement the super methods either through override or overloading the prod conditions. Out and the return value should be as strict as or stricter than those of the superclass. Let's look at the following example here. We have the coder. Yeah. Here the Java coder inherent from the coder. Extend and inherit the thing without overriding any super. Yeah, without overriding. It also extends the functionality by adding its own method scheme with compile with the Liskov principle. This is one, let's examine in the different example here. In this case, we override the coding in the Java coder, which changed the original behavior of the superclass. This violated the Liskov principle because the superclass no longer preserved the original behavior of the superclass, right? So if a program doesn't know how to code, can they still call a programmer? In this situation, inherent from the coder is no longer suitable. Instead, we can promote the behavior to a more generic class, people, to refine the structure. You can see coding, right? Coder expand people. We can use like, I know the code, yeah. Java coder, people. Like game. The strong display, right? And the coding, this is override is. It's an important way to achieve open source as well. So it's kind of like just to inherit something. Just make sure you do the right inherent, right? So inherent something, and you can work that to the you can better to add a new function, not to change the original one. So that is called Liskov substitution principle. The third one is interface segregation principle. The interface segregation principle focuses on refining the interface. Yeah, clients should not be forced to depend on the interface they do not use. So when we define the interface, it's essential to control their granularity. It means quality something. Here is an example, right? We have the devices. Smaller this. We have the devices here, and the computer to implement this the interface, and the fans also to implement this phase. So although we define the device, it's right to where it works well for the computer, but it's not suitable for the fan. We don't have some memory something for the. So it can improve where we don't need, right? And for here we can see by dividing the interface into finer, more specific interface, each type of device can implement only the interface related to it. However, we should avoid over segregation and keep interface practical and based on the real requirements, right? So we better to separate it. So the whole purpose for that is to match for the something I don't need. Okay, so like for here, right, we have the robot want to implement the worker, but it we don't need it. So actually I don't need to implement the worker. So we better to use another or separate the worker, like workable, eatable, then a robot or human can implement different interface. And the 5 here is dependency inverse principle. The dependency inversible principle is a fundamental principle. Fundamental in all object-oriented design. A great example of its application is the Spring Framework. So high-level modules should not depend on low-level modules. Both should depend on the abstraction. Abstraction should not depend on the detail, but the detail. Sorry. Okay, but the detail. Where I now? Okay, but detail should depend on the abstraction. This one? Okay, interface define the function, right, without main upper string. Now imagine one day company change the requirements and the user need to be replaced within a new implement. This one, new implement. As we see, each modules are directly depends on each other and create a tight coupled structure. And any change in the lower modules, like replace user service, directly impact higher level modules that depends on it. So in a larger project, this modification will be overwhelming and difficult to maintain. So the purpose for that is like if you are the high level, right? And a lot of things depend on the high level. If you depends on the detail, and the detail is more change frequently than the high level. So when the detail you change something, it will happen something wrong, and at the high level also will need to change. So the purpose for this one is less frequently to change. So as we see each module directly, yeah. So the purpose for the dependency inversion principle is here. And a good implement is the Spring has the dependency injection. Is a good implement for this principle. Yeah. So this is the solid principle. Thank you.